the stylus shortly. But for the first, let me put up what do we need to do. Okay, so this is item 1, set builder notation. I'll extend it. Okay, this is what we asked to do. Given the figure Z below, I have 3 of them below. How would you put those kind of intervals, right? Intervals in set builder notation. Okay, so here is the question. And then I'm going to use the styler to put the pictures in. You know, I'm very sorry, they will not be very cute because I have to, okay, here comes my ceiling, right? Because I have to use a styler and now this will be A, item A, and you know, the straight line is not always very straight. Okay, so here is what I have. I have a 0, 1, 2, 3, 4, -4, -2. So I won't put all the marks in. 1, 2, 3, 4, 5. Okay, so this is 5, this is 2, this is 4. So some of them, right, to keep it easier for me. And now let me draw the interval. I'll use the orange and the thicker, and this is what I'll do. I'll do a point here, and then I'll go to the left. Okay, so this is the first interval. And while I'm putting the rest, think about the first one, okay? Okay, so this is B, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 2, 4, 6, 8, and then the next one. Okay, and I need the thick line. Okay, -1 like this. And then I'm going up to the 6. Okay, and then the last one. Okay, so this will be C. What do I need? Okay, so this one, -2, -1, 0, 1, 2, 3. I'm trying to be consistent because the distance should be the same. 4, 5, let me extend it, 6. Okay, and here comes my purple one. Okay, from -1 up to 2, and then from 4 and there. Okay, looks nice. Okay, so I'm back here, all right? Now, when we do the set builder notation, we always put those curly braces around, right? So this is what we can always start with. So what I will do for the first case is I'll open the curly braces, and here, open the curly braces and open the curly braces. Then I'm used to putting the variable. Now, in general, we are doing everything in terms of X, but if you saw something like the information given to you, and maybe they say that the variable is T, you will put T there. But in general, we will put the X here, and then the bar. The bar stands for the word such that, right? So X such that, X such that, right? So the bar, let me put up, okay. Bar stands for such that, right? So all the X's such that, right? And then what we usually are required to do if we are dealing with the real numbers is we should say that X belongs to the set of all real numbers. Now, what are the real numbers? 1 is a real number, -2 is a real number, 2.5 is a real number, square root of 7 is a real number, negative square root of 2 is a real number. So all those numbers that we can think of, right? Not complex numbers. We will talk about the complex numbers just a tiny bit if I remember it correctly. But so the R stands for real numbers, right? So usually one would put them over here. So EX is a real number, but what we do say is we have a convention of not putting it, not overcrowding the requirements after the bar, after the such that. So we would usually omit it. And you probably noticed it in the Xi books as well, because when they were using natural numbers, right, the ones that are 1, 2, 3, 4, 5, and so forth, they were using the n, right, and they were putting the conditions. When you were using the integer values, Z, right? Z stands for it. So it's like -4, 0, +5, and so forth, all those, right? Right? You were using the letter Z. But when we have the set of all real numbers, we usually omit it. Then we put the restrictions. So this is how it sounds so far. So all those real values for X such that, and then we put the restriction, right? Now the restrictions are given to us by the graphs, right? So, for example, how would you read this restriction over here? Right, think about it. How would you read it? X is what?
X is less than 3.
X is less than 3. Now let's see, is it included?
Yes.
So we will say X is less than or equal to 3. I'll go ahead and put it. X is less than or equal to 3. That's it, right? So what I'm saying over here is quite often what we saw in our solutions, right? When we were putting the solutions for equations that we saw before, that's how we did it, but without the curly braces and the bar, right? So that's why I like the set builder notation. Like whenever you get the answer, you just surround it with the curly braces, put the X and the bar and the vertical line, right? And say, that's it, right? That's done. With the intervals, you have to realize whether I'm using the parentheses or the square brackets, right? So check this one out, right? So what I have here is a small interval. Small, I mean that it doesn't extend to infinity, right? Like over here, you see that the orange line goes indefinitely to the left, right? So it's all those negative values and the +1 and the 2 and so forth, right? Now over here, it's an interval, right? It's a fixed interval and it's like a line segment to us, right? With the name we could use from geometry, right? A line segment with restrictions on the end. This end over here is excluded, and this one is included. So for this one, I'll use the strict inequality, and for this one, I'll use a less than or equal, right? So here, immediately I could put less. Here, I could put less than or equal, put the X in the middle because it is guarded from both sides, right? So it only can be, one in between the -1 and 6. And then I put the answer here, -1 and 6 here, right? So because it was not short, right? But it was just an enclosed interval, right? It's not extending anywhere. I am using the X in between the two values. So it's guarded, right? From both ends. So closing it. Now, think about the last one. Think about the last one. I have 2 line segments there. When we have 2 line segments, we usually use the union symbol. So this symbol union stands for that and the other part, right? So that we would like to join 2 intervals. So X could be either from here or from there. So when I will be putting up the answer here, I would use this union, right? Union. It's like U. It looks like U, right? So, but I'll be using this union symbol now. I would like you to think for a moment, and you can either put it into the chat messages, you can say it out loud. What 2 boundings, like here, you would put on the left and on the right, right? Like what would you say, right? So everywhere X will be in the middle, right? But then, oh, no, I'm wrong. Here, X will not be in the middle. So here we will have X something, right? So one of them will be like this, another will be like that, right? So think about it. What would you put into those conditions, right? After the words such that? Which two intervals will you unite? Okay. Think about it. So put your answer either into the chat messages or you can just say them out loud. I'll give
2
you.
and 4.
Uh-huh. So yeah, you're saying about 4, right? X is?
Yes.
Uh-huh. Say how would you write it?
4. X is 4. And I would put,
Uh-huh. So I got it. So X is not 4. X cannot be 4 because you see it's excluded.
oh yeah,
But X should be what? Greater, right, than 4.
right.
So you will put X is greater than 4 here. So X could be 5, X could be 6, X could be 4.1, right? But it cannot be 4, right? Mm-hmm. What would you put for the first one? Right? Think everybody and put the answers into the chat messages or just, speak up.
-1.
Okay, -1 here. And I'll open the chat messages meanwhile. Yeah, Nicholas, Sam.
Equal.
Equals or less than? Over here, which sign? Less than, or equals, less than or equal, which one to put?
Less than.
Less than.
Okay, less than. Agreed. What to put here? So what to put over here, right?
2.
2. And what inequality? So we have less than, or greater than. I'm not choosing the greater, right? Because it's in between, it's less, it's to the left of the 2, right?
Less and equal.
Yeah, less than or equal. Yeah, I agree. So here is the trick, right? Once again, with those intervals. If I see it over here, then it means that my values of X, okay, not my, X's values, are bound. They should be staying in between -1 and 2. So that I know for sure, right? And I can put those numbers right away, -1 and -2. And then I can decide about the inequalities, right? So X should be greater than the -1, right? Because it's to the right of it. And then it should be less than or equal to 2 because it's to the left of the 2, right? So if it's to the left, we use less than or less than or equal. If it's to the right, then we use greater or equal to. But because we read it from left to the right, we look at it from the position of 1, right? So we'll say that -1 is less than X, right? Just because the way we read it is always going from left to the right. So this is what I want to say. Let me put these two things. One thing I can say is that -1 is less than X. And the other thing I can say is that the X is greater than -1. It's the same thing, right? It carries the same information. And what we used to do when we were solving the inequalities, right, is we used to have them usually in this case, when we had the simple ones. And then when we had the compound ones, right, we had 2 options. If we have or, then it will be or and some other one, right? Oops, sorry, I switched my screen from the other one. You won't see it, but if we had the compound one, then usually X was guarded by something, right? So that's where we kind of encountered it for the first case, right? For the first time. Okay, so just I want you to make sure that you understand that saying -1 is less than X, right, carries the same information as saying that X is greater than -1, right? The first one is talking about the position of -1, right? That it's always to the left of X. And the second one is saying that x is always to the right of the negative one. Okay. Let me know if you have any questions. Mhm. Everybody's doing good so far? Okay. So let's go to the next one then. This will be the interval notation. So item 2, interval notation. Okay, now over here, we will be given different figures and we will be asked to use the interval notation for them to put them in this notation. So given the figures below, how could you put those intervals in interval notation, right? Okay, and then let me do some drawing. So I'll stop the video, you don't want to see my ceiling. And then let me put them up. So item A will be this. I have only 2 there. So we start -4, -3, -2, -1, 0, 1, 2, 3, 4, something like this. And then let me use the orange and I'll use the thick one. So I'm starting over here and going to the right, right? And then the B. I didn't change the thickness. Okay. So -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, enough. 1, 2, 3, 4, 5. Now here is the interval. From -4, I need the thick one to this 0. And then from 2 to 4. Okay, 2 intervals. Now, while you're thinking about it, let me remind you, let me turn my video back on. Oh, I don't see myself. Okay, this way you should be able to see me. Okay, so when we are talking about the interval notation, what we need to recall is how to use those brackets, right? So when we include the points, right? The one that are shaded, right? We use the square brackets, depending on what situation we are in, right? Are we opening it or we are closing it? When we exclude the points, right? They usually show it as circles on the graph and we use the parentheses, right? In one way or the other. That's why, by the way, quite often what they used to do before is they didn't use these 2 points, but they used to do parentheses, or the square bracket, something like that. So instead of the points, they were using those symbols right away. It's nice from one point of view, but then, they decided that it looks nicer with the points, circled or not. Because circled, not the circle, the shaded. Shaded means take it. And then the circle not shaded means don't take it. But then we still are left with the parentheses and the square brackets when we put the answer in, right? For the interval notation. So think about the A and B. Can you please put your answers into the chat messages so I can see where are we, how are we doing, and do we understand how to use the parentheses and the brackets? Okay, I'll give you a few minutes for that. Maybe let's say 2-3 minutes for that. Okay.
Miss, sorry, to do what? This one?
Yes, so you're working on the items A and B. I'm
Okay.
asking you to put the answers into the chat message because I want to see like how are you doing do you understand what to do with the brackets and with the parentheses?
Okay.
Can't find the infinity symbol on my computer.
Yeah, I know. So usually I put inf, like the 3 letters, inf there, or infinity. I think the web work understands both of them, inf and infinity, but you have the math quill, it's much better with it. So, yeah.
Once I put the infinity button, I can put back the parentheses, right?
Yes. So since you already mentioned it, infinity always comes with the parentheses. We do not include the infinity, right? So, and I'll tell you why. There is no a number which we can call infinity. Infinity means usually that we can go forever, you know, to the left, to the right, whatever it is. If we go to the left, we call it negative infinity. If we go to the right, we call it positive infinity, but the plus sign usually is omitted, right? So I'll put out some of the examples for you, right? So whenever the infinity is used, just use the parentheses because we cannot find that largest infinite number, right? It's always a number more than that. That's why we cannot include it. We use the parentheses there, okay? And let me answer other chat messages.
Yeah, I noticed after I sent it that it was wrong.
Yeah. I thought that I muted myself, but I didn't. But this is the goal. So it's okay to send the wrong answer because at least I know how to explain, right, it to you, how to correct you. So that's the goal of the chat
Yeah.
message. Okay. So keep in mind, interval notation is always something with the square bracket or parenthesis opening or the square bracket or parenthesis closing. So it's always these two, right? And then in between, it's a comma. So here, we do not put the X, that X is greater than 2 or something. Here, we only use the numbers to show where the X is, right? That's quite often, that's why quite often you might see something like this, X belongs, right? So this one stands for belongs to interval, right? Now, check this out. This is inclusion. So I would use the square bracket for it. So starting from the -1, I'm going to, and I'm like, well, I'm going to infinity, right? So that, you know, how would you do it in writing? You would put this symbol. How would you do in web work? You either choose it from the math quill panel, or you could say inf. I think inf worked, and maybe infinity. I'm not sure about the second one. I always have to Google for it, to tell the truth, because I forget
It's
myself.
inf.
Inf.
For web work, for web
Crossing it
work,
out.
it's
Okay.
inf.
Inf, thank you. So inf, right? And then once again, infinity always comes with the parentheses, right? So it doesn't come with the inclusion symbols, okay? The second one, we won't have in the infinity, right? We won't have it there. What we will have is, you see this is shaded, so I'll put this. You see this is not shaded, right? It means exclude. Do you see that there are two intervals? So similar to that set builder notation, right? Example, I'll put the union symbol here, right? And then this one, do you see shaded? Included. Oh, don't forget to put the comma, right? You see this one shaded? Put this and put the comma. And then you can fill out the numbers. You could do it right away. But this is kind of, you know, shows you how do I do the mapping, right? And always we have opening direction and closing, opening and closing, right? So it's kind of enclosed into them. Okay, so here we started with the -4 and we went all the way to the 0. And here we started with the 2 and we went all the short way to the 4, right? So that will be the answer for the interval notation. Okay, now when I have something like this, I'll put the C in. Okay. 2, -1, 0, 2, 3, and 4.
So this
Mhm.
recording will be up, right?
Yep, it will be available. So usually I put it out either the same day or the next morning.
All right.
Okay, so let's take a look at this one. I want the yellow one and I want the thick line. So for example, I'm starting here and I'm going to the left, right? Now what it means is we are going into the negative numbers, right? And this 3, it will be excluded. So let me go back to the thin writing. So this will be excluded, not the square bracket, right? So not the square bracket got excluded, comma. And then this will be the negative infinity. So I'll put the negative infinity in, put the parenthesis, right? Because the infinity always comes with the parentheses only. And I need the negative to show that it's to the left. I don't know how you see me. Let me see. How do you see me? How do you see me? Left. Is it left to you? Left, right? Left, yeah. So it goes to the left, right? So it means the negative infinity. Yes, Lane, I agree with you. So onto 3, right? Onto 3. Okay, like that. Okay, let me know if you have any questions. And while you're thinking about it, I'll try to organize a little bit my screen. Okay. Everybody is doing good? We are doing good, yes, in terms of time. Excellent. Okay, so let's merge it with the material we covered before. So it will be, once again, practice for the topic today, and it will be practice for the things we did before, namely inequalities. So let me put up 2 inequalities for us, which we are asked to solve. One of them is compound, and another is just the inequality. So the other one comes first. It's like the easier one, right? Let me clear all the drawings up and let me put up the text. What do we need to do? Okay. Now I already scanned it, so I'll put it up online today. The only thing is this time it's handwritten because I had to do the intervals, so it will be handwritten. I apologize. So solve the, this will be item 3, right? So solve the given inequalities and, okay, no, graph the solution sets and put the answers in both notations, okay? So this is what you usually do in real life whenever we are solving inequalities. And once again, where do the inequality come from? From some real, real world event, right? Usually what we do is we build the model, something happened. We build the model and then we solve it to get some answers for our research, right? For our model. So let me put up those equations in. So A, fractions. So let me do the styler. Okay, x over 6 plus x over 5 is less than or equal than 11. Okay, let me put the second one and then I'll make some comments and show like the first thing what we should do there. B. Okay, this is with decimal numbers. Negative 1.43x minus 12. Okay, here I'll have the symbol less, but the second one will be less than or equal, so I'll have to draw it. 1.57x minus 15. So this is the less than or equal place symbol, negative 1.43x plus 18. Okay, didn't fit in. Let me move it a little bit. Let me stretch it. Okay, this is much better. Now let me put in the simple. So the second one was less than or equal. Less than or equal. Okay. First inequality has fractions, right? So what I have to do there first is find the LCD and multiply both sides by it. Give it a moment, you know, to think about it. So I'm looking for LCD and then I'm multiplying both sides by it. This will do together. We'll find the LCD together and then I'll show you like the multiplication. Then you will be working with that. Now, for the second one, check this out. I have three sides. This is one side, this is second side, like the middle one, and this is the third side. The idea for me is to get at the end of the day something like this, right? Number here, number here. So number constant, right? Number. Okay. So what it means is that I need to get rid of these two. And thankfully, they are the same. So if they were different, I'd be in trouble. It will not be that easy for me to solve, right? But since they're the same, what I will do in this case is I will add 1.43x to all three sides. This will eliminate the x from here, and it will be only in the middle, okay? So that's the strategy for this type of problems. So once again, plus 1.43x plus 1.43x x plus 1.43x, right? So once again, because I want x to be in only one side, namely the middle, right? Because the answer must be in this form, right? So that's the strategy for this one. The strategy for the first one, tell me what's the LCD? Who knows what's the LCD? Give it some time, don't worry.
Is it 2?
Not 2. So LCD is the number that divides both, that is divisible by both, by 6 and by 5. So it can never be less than any of them, right? So once again, you should come up
30.
30, yeah, 30. So 30 is divisible by 6, no remainder, right? And 30 is divisible by 5, and it's the lowest possible. Okay, Elaine, I'll reply. Okay, so let me put it up. LCD is equal to 30, right? Now, if the LCD is 30, I can get rid of the denominator by multiplying both sides by the 30. And here I'll put the 30 here, 30 times. Now, what I will have to do with the left side is use the distributive property to multiply 30 by x over 6 and multiply 30 by x over 5. That will cancel the denominators. You'll see the simplifications there. And this one I can just multiply out, right? Okay, so I'm giving you 5 minutes to work on these problems. Put the answers into the chat messages, please, if you get them. I don't ask you to graph it. Just put the answer that we usually get at the end. And then we will put them in both set builder notation and the interval notation, okay? Resume recording, okay? So the first part will be missing, but at least, you know, we'll be able to see the solution, right? So let me know if you have any questions about the solution of item A.
Yeah, why are you dividing like 5 by 5?
Dividing by 5 because I'm canceling, right? Check this out. Yes, you see that they have common factor of 5, right? And the common factors we usually cancel to simplify fraction.
So why like in 130 there's a 5 and then another one there's a 6?
Because they were canceling different factors. So over here, the common factor of this numerator and this denominator is 6, right? So I'm dividing this one by 6 and I'm dividing this one by
Oh,
6.
yeah.
Just, yeah, just because common factors are different.
I didn't see the 6.
Uh-huh. Okay. Okay, now, with the compound inequalities, this is the inequality of the type AND, right? So when the x is usually between the two bounds. Now, this one was weird because we had these expressions with the terms with the x on the left side and on the right side as well. And the trick I told you is what our goal is to have the x in the middle. So I'll need to get rid of these two terms. How? The only possible way for me is to apply the operation to all three sides. And here, because they were the same terms, right? If I added 1.43, they will cancel. If I add the 1.43x, they would cancel. But I'm supposed to do it to all three sides. So over here, I also have to do the addition. But this addition is nice because it converts this to 3, right? Because 50.57 plus 0.43 gives me 1. 1 and 1, 3, right? So we are getting negative 12 less than 3x. Don't forget the negative 15. So minus 15 and less than 18. So these ones we saw, right? And these ones we are more used to. And once again, if I were not able to do that, I will not be able to solve it, at least here and now, right? Now,
That's exactly what I got. And I added plus 15. I didn't know which side I was supposed to do first.
Yeah, the rule says all the sides, right? All the sides. So if, and you're absolutely right, you're looking at the right place. You want to get rid of this 15, right? So this is the first thing you do. But the rule says both sides, when we have like only one inequality symbol, the more we get, we apply it to all the sides. So I should add it here and I should add it here, right? Because the information must be updated consistently, right? So I do have to change the bounds as well. Okay. Now, from here, we will get positive 3, right? Less than 3x. These two canceled. And then from here, 33. Yes, I remember it was 33. You know what I did? I forgot to put this equality, right? So I lost it. Typo, tension lag, something, but I forgot it, right? Okay, so don't be surprised if you are doing this mistake. We are all human beings and sometimes we just miss things. Now, the last step for me to isolate this x would be to divide by 3. And the same reasoning here. Since I do it to this side, I have to do it to all the sides, right? So from here, I'm getting 1. From here, I'm getting x. From here, I'm getting 11, right? So that's that answer that I had over here. Now I need to graph it. And what I will do, I'll fit in the graph over here. I'll use the black line. So black line, what I do is I just show 1 and 11, and I don't care about anything else. That's really funny. Let me check the chat messages. Okay. Now, this one will be included, this will be excluded. So let's grab the yellow one. I'll do the thick line. So I exclude this one, I include this one, and I shade everything in between, right? Now from here, I will do the interval notation, right? I can use the interval notation. So I'll say from 1 to 11, including. Very funny, right? Like this will be the interval notation answer. And from here, I'll use the set builder notation. I'll say all x is such that 1 less than x less than or equal to 11. So that's my set builder notation, right? And that's our graph. So kind of 3 things: graph, set builder notation, and the interval notation. as well as here, right? So we had interval notation, the graph, and the set builder notation, right? Okay, now I'm back and I can turn on my video so that you could see me and I could see myself. Okay. Okay, so how does it look like? Any questions?
So we're gonna have it homework today.
Yeah, so the homework today will be based mostly on the set builder and the interval notation, but also you will have some inequalities to solve that will have the, I think they will be asking you to put the answer in interval notation. Let's go to the homework. So let me share our web page with you. And
The homework you gave me, I supposed to do that today, right? Only the homework I have to do it.
Okay, so what you will have to do with the homeworks is when you go there, right, when you log in, you will see which homeworks I assigned. So far, the last assignment of the homework is the homework number 4, right? So homeworks 1, 2, 3, 4 are all assigned. Today, I'm assigning the homework number 4. So these are all the homeworks to do, okay? Let me move this. And I'll stop. Okay. Now, so let's take a look at the homework number 4. It has 7 questions. And I do remember that here you will put the interval notation. So you need to solve it and put the interval notation. And they say what to use. But
I cannot see your screen.
say it again.
I cannot see your screen.
You cannot see the screen. Give it a moment. You should be able to see it in a few moments. Sometimes it's the internet connection. So then it means that I should wait. So everybody could see the screen. Okay, everybody could see the screen?
Yeah, I can see.
Yes, I can see.
You could see it, okay.
Yeah.
Excellent, excellent, okay.
Let
Yes.
me go and come back.
So you see what they say here as infinity, but no, as inf, right? Sheldon said that it was as inf. So when I click over here, you would see the symbol here, right? And it says inf there. I have, because these are problems, sometimes I have to modify them for the comments to be correct. But so this one, when you need to solve an inequality, here, that's this compound inequality, but it's only one-step solution, right? And interval notation that they're asking us for. This one, right? It's that inequality with a fraction, which will be easy to get rid of. Just flip it and multiply by the reciprocal, right? All the sides. So, and it's also interval notation. I remember that there was, here. Here we see that it will be the set builder notation and the interval notation at the same time. And you see, you are always given an inequality to solve, but they are fairly easy. Like the previous wasn't that easy, right? Because you have to do several steps there. But these ones are usually pretty easy and you're always asked to solve an inequality, right? Just not do a picture. I think I just didn't find any pictures there. So that, the ones that you could use. So over here, right, you would use the LCD, like the one that we did, right, with the LCD. It's the same LCD theory, right? And they want you both notations to be used, okay? And then I think that, yeah, that's kind of, where is the inequality here? Or, but here you're given all the comments. So you should be okay with putting the answer in. And once again, you see this union symbol, since we have the math quail, it's present there, right? U, just the letter U otherwise, right? And then this will be the last one, right? So this is another compound inequality. Okay, so you don't see the pictures like we used to see in the Xi books there, right? Because that was mostly about the picture and then have it. We are kind of merging it together because this is how usually the things are in the real world. Okay, so 7 problems only, I'm not giving you too much because 7 is good. amount of the problems to work on. And once again, don't hesitate to send me an email if you think that your answer is correct, but the system doesn't accept it. I'll check it out and I'll tell you how to put it correctly. Okay, now, maybe just few minutes, let's have 3 minutes for us to just, kind of set aside all the thoughts and get ready for the Kahoot quiz, right? So as I told you, it will have 3 questions. Every question will be timed at 4 minutes. And after we will be done with it, I think we'll have time for at least like one more question to do. I have one more question for us set aside for the extra practice. Okay. And just, 3 minutes for us to recuperate from all the information. I'll mute myself, but I'm here and I will stop the recording